The cube root of 4 is equal to, A says 2 times the square root of 2, B says 2 to the power 3 on 2, C says 2 times the cube root of 2, and D says none of the above. So generally what we are going to be doing is that when I display the equation, I give you the solution, and then I take the answer for the 5 questions that we are going to do now. Alright, so as per the solution to this question, the cube root of a number, that's the cube root of 4, is the same as 4 raised to the power 1/3 from the basic laws of indices. The n root of a number is the number raised to the power 1 on n, provided the number is positive. So the cube root of 4 is equal to 4 raised to the power 1 divided by 3. Now 4 can be written as 2 squared, so we get 2 raised to the power 2, or that raised to the power 1 on 3. But there is another law of indices that says that if I raise a number, if I raise something to a power and then I raise the results to another power, I can just multiply the powers. So here I'm just going to multiply 2 and 3 because they are the powers that I'm raising to. So at the end we get the cube root of 4 to be identically equal to 2 raised to the power 2 divided by 3. So if we check here, we don't see any option like that. So we need to verify these options, if any of these options can boil down to 2 raised to the power 2 divided by 3. I use 2 because all the options here I can find 2. That's why I needed to simplify it, let it resemble 2. Alright, so let's begin with the first option. The first option is 2 times the square root of 2. Remember, the square root is like 2 raised to the power half. So it means you have 2 times 2 raised to the power half. When you're multiplying numbers of the same basis, you add the powers. So you get 2 raised to the power. Here is 1 plus half, so it's 3 on 2. So it's 2 raised to the power 3 on 2. So we see that option B is already wrong because 2 raised to the power 2 on 3 is not the same as 2 raised to the power 3 on 2. And since option A is 2 raised to the power 3 on 2, automatically, and option B is also 2 raised to the power 3 on 2, means option A and option B are wrong. Now let us look at option C. Option C says 2 times the cube root of 2. Now 2 is to the power 1 and the cube root of 2 is 2 raised to the power 1/3. When you add the powers, you're going to get 2 raised to the power 1 plus 1/3, which gives you 2 raised to the power 4 divided by 3. So 2 raised to the power 4 divided by 3 is not equivalent to 2 raised to the power 2 divided by 3. So it means that the correct answer is option D. Alright, so let's move on to question 2. Question 2 reads, let f of x be equal to logarithm to the base 2 of 1 minus x squared. Then f is defined for all x in the set of real numbers such that A says x is greater than 0, B says x is different from 0, C says x is the absolute value of x is less than 1, and D says x belongs to the set of real numbers. Alright, so our f of x is a logarithmic function, and for all logarithmic functions to be defined, their arguments should always be greater than 0. It should not be equal to 0, so it should be different from 0 and greater than 0. So all we need to solve here is, because the base is already defined, the base is 2, the base is not 1, and the base is not 0. So we are okay to just use the argument. The argument is what we are computing the logarithm, the function in which we have to compute the logarithm. That's the argument. In this case, the argument is 1 minus x squared. We all know that if we're in the set of real numbers, the logarithm of functions are defined provided that function or that value that you're computing the logarithm is always positive. Positive means that you're greater than 0. Alright, so here our argument is 1 minus x squared. So for the logarithm to the base 2 of 1 minus x squared to be defined, then we just have to solve the equation 1 minus x squared greater than 0. Because if it is less than 0, we cannot compute the logarithm. We can compute the logarithm, but the response is going to be in a set of complex numbers. But here we are working in the set of real numbers. So the logarithm to the base 2 of 1 minus x squared is defined for 1 minus x squared greater than 0. Alright, so if I divide all through by negative sign and I send 1 to the right hand side of the equation, and I divide all through by the negative sign, I get x squared minus 1 less than 0. It means x squared is less than 1. Remember that there is a rule that says that whenever you divide or multiply both sides of an inequality by a negative sign, the inequality sign reverses. So here reverses from greater than to less than. Alright, so you can take the square root on both sides. So on the left hand side you get the square root of x squared, on the right hand side you get the square root of 1, but the square root of 1 is just 1. So don't be confused, the square root of a number is always positive. So the square root of 1 is not plus or minus 1, but it is just 1. Alright, so the square root of x squared is less than 1, but the fundamental definition of the square root of x squared is the absolute value of x. So the absolute value of x will be less than 1. So option C is correct. Nevertheless, this option can still be dissolved into negative 1 less than x less than 1. But since we have our option there already, then we can continue. So option C is correct for question 2. Alright, so let us proceed to question number 3. It reads, let f of x be equal to the cosine of 1 on x, then f is defined for all x in the set of real numbers such that a, the absolute value of x is greater than 1, b, x is different from 0, c, x belongs to the set of real numbers, and d, x is not equal to k pi, where k is an integer. Alright, so there are some basic things that now we need to tell you guys. F of x, that's a cosine function. The cosine of any function, the domain of definition of the cosine of any function is the domain of definition of that function. Now here I'm computing the cosine of 1 on x. So for the cosine of 1 on x to be defined, I just need to look for the domain of definition of 1 on x. So the domain of definition of the cosine of a function depends on the domain of definition of that function. So if I call g of x to be equal to the cosine of 1 on x, it means that my f of x is just equal to the cosine of g of x. Now clearly, by the previous definition, it means that the domain of definition of my function f is the same as the domain of definition of the function g. Now what is the domain of definition of the function g? It is 1 on x, so it is a rational function. So it is defined such that its denominator is not 0. So it is defined for all x in the set of real numbers excluding 0, which means x is different from 0. And since the domain of definition of f depends, or it is actually the domain of definition of g, then we can conclude that option B is correct. The domain of definition of cosine of 1 on x is x in the set of real numbers excluding 0. So option B is correct. Alright, so question 4, it reads, in a box there are 10 colored stones, 3 white, 2 yellow, 2 green, and 3 black. By randomly extracting a stone from the box, what is the probability that it is a white or a black stone? Here are the options. A says 3 on 10, B says half, C says 1 on 3, and D says none of the above. Okay, so we are just going to consider these colors as events. You have 3 white stones, you have 2 yellow stones, you have 2 green stones, and you have 3 black stones. Now what happens is that we extract randomly from the box a stone, and then we have to find the probability that the color is white or black. So we first of all get the general review of the probability of the union of 2 events. So the probability of white or black, meaning probability of white union black, is equal to the probability of white plus the probability of black minus the probability of white and black. But these events are mutually exclusive, meaning that there is no intersection. No intersection means that no intersection between the 2 events. So it means that when you extract a ball from a stone from the box, it is not possible for the stone to be white and black at the same time. Why? Because all the stones have unique colors. As you can see, we have 3 white, you have 2 yellow, you have 2 green, and you have 3 black. There is no stone with 2 different colors. So it means that it is not possible for you to extract a stone from the back having a white color and a black color. So the events are said to be mutually exclusive, and with that said, it means the probability of white and black is 0. So it means our probability of white or black is just the probability of white plus the probability of black. Now what is probability? It's just the number of favorable outcomes divided by the total number of outcomes. Now, so the probability of white is going to be the number of favorable outcomes, which is 3, divided by the total number of outcomes, which is 10. So we get 3 divided by 10. What about black? We also have 3 blacks as it was given. So those are the favorable outcomes. And then now the total number of stones, we have 10. So probability of white is the same as the probability of black, which have a numerical value of 3 divided by 10. So it means the probability of white or black is equal to 3 divided by 10 plus 3 divided by 10, which is 6 divided by 10, and it simplifies to 3 divided by 5. So looking at the options, we see that there is no correct option. So there is no 3 divided by 5. So the correct answer is going to be none of the above, which is option Z. Alright, and lastly for this video, we are going to look at question 5. It reads, for each n greater than or equal to 1, the logarithm of n plus 2 is equal to, A says logarithm of n plus logarithm of 2, B says logarithm of n plus logarithm of 1 plus 2 on n, C says logarithm of n times logarithm of 2, and D says none of the above. Alright, so let's get the solution. If n is greater than or equal to 1, it means that our n plus 2, we can divide all through by n. With the concept that n is greater than 1, meaning it cannot be 0. But if n was 0, then we cannot divide all through because we don't divide by 0 in maths. So n plus 2, we can factor out n. So factoring out n from n, we get 1. And factoring out n from 2, we get 2 divided by n. Similarly, if we multiply all through by n, we get n times 1, which is n. And then n times 2 divided by n, which is 2. So it means if you compute the logarithm on both sides, it means the logarithm of n plus 2 will be the same as the logarithm of n into 1 plus 2 on n. Now I can just call this n here as maybe A, and then 1 plus 2 on n, I can call it B. Now there's a lot of logarithms says that the logarithm of the product is equal to the sum of the logarithms. So it means that this is equal to the logarithm of n plus the logarithm of 1 plus 2 divided by n. Similarly, if you want to combine these two logarithms, you just take the logarithm of the product of the arguments and you get back to this response. So clearly the correct response is option B. Alright guys, so here we come to the end of this video. We have succeeded to solve the first 5 questions of the engineering cycle, mathematics specifically. The questions came in the entrance examination into the National Advanced School of Public Works in Yaoundé. So in subsequent videos, we are going to pair maybe 10 questions, maybe 15 questions, maybe 5 questions, depending on my availability. So for those of you who have not subscribed, please endeavor to subscribe to the channel, share the video to your friends, invite them as well to subscribe to the channel. Now for those of you who are preparing for entrance examinations into the Faculty of Engineering in Boya, the College of Technology in Boya, the National Higher Institute, the National Higher Polytechnic Institute in Bamenda, I'm going to upload the past questions of those concourse, the mathematics section specifically. So stay tuned and see you in the next video.